I'm going to go through three important examples, they're all in chapter 19, starting on page 324. A solid metal sphere is made of lead and it is recast to form a cylinder of radius 8.1, height 6, and you have to find the radius of the sphere. Now what you can do there is this. A solid metal sphere is melted down and recast to form a cylinder. In other words, the volume of the cylinder is equal to the volume of the sphere. And that's a very important fact to recognise. So the volume of a cylinder is pi r squared h, and the volume of a sphere is 4/3 pi r cubed. So in other words, you didn't lose any lead when you were remaking the object into the cylinder. Leave pi in it, because we'll get rid of pi from both sides later on. You're told that the radius is 8.1. Yes, you are. And that the height is 6. And we know very little about the sphere, but we need to find the radius of the sphere. So I'll put in all the information I have, and all I'm missing is the radius of the sphere. That works out to be 393.66 pi, and this side I couldn't do much with. But divide by both sides by pi, because this side is multiplied by pi, this side is multiplied by pi. I'm allowed to do that, and I get this. Now multiply both sides by 3 to get rid of that 3 underneath the line. Now I don't want 4r cubed, I want r cubed on its own. So I divide both sides by 4. So ultimately what I have done there is that 4/3 that was here, I brought it over here, and by the time I was finished it became 3/4. Put that into the calculator, that's r cubed, get the cubed root of that. Cube root is on your calendar, or your calculator. There, excuse the dirty calculator. And the answer there turns out to be 6.66, correct to 2 decimal places. The next example I'm going to look at is not that difficult, but it can be a weird concept for some people. Water is flowing through a cylindrical pipe at a speed of 35 centimetres per second. So in other words, every second this much pipe disgorges the water into the tank. It is a bit like filling that section several times and putting it in the tank. I'm going to go here to my example. So here's my drawing of the pipe, which is cylindrical in shape. Every second the volume of the cylinder drawn above pours into the tank. This is an important fact to understand. The amount of water in the tank will be a number of these cylinders. So the volume of one cylinder is pi r squared h, or that's the volume for 1 second. So pi r squared h, taking the information there about the cylinder or the pipe. So the volume of the cylinder is this. So every second 2,750 centimetres cubed flow into the tank. Now, how many seconds are in 5 minutes? Because I want to find out how much water flowed into the tank during the 5 minutes. So if I find out how many seconds are in 5 minutes, that's how many of these I will have. So 5 minutes, 60 seconds in each minute, so 300 seconds. So I will have 300 of these cylinders in my tank. I did that there, so it's 825,000 centimetres cubed. As an aside, that's 825 litres. The volume of the cuboid is the volume of the tank, which is that, and that's linked by width by height. I have two of the measurements, which are 100 and 100, but I don't know the height. 100 by 100 is 10,000, and that gives me a height of 825 centimetres. Okay, and the next example I'm going to look at is another important theory. You come across it in science, Archimedes' principle. If I immerse a stone in that water, the amount of water that's displaced is equal to the volume of the stone. So I'm looking at the example, which is over the page here. That's example 19.15, and here it is. So I have water that goes up to this height in a cylinder, and I put in this ball, and the water height goes up by this yellow part. I can say that the yellow equals the yellow because the volume of the sphere is equal to the volume of the water displaced in the cylinder. In other words, the two volumes are equal. This is an important fact to understand as well. So the volume of the sphere is equal to the volume of the water displaced in the cylinder. Cylinders are this shape, pi r squared h, and spheres, I got the formula from page 10 in the log tables. Now I do know the radius of the cylinder, and I know the radius of the ball. So 4/3 pi r cubed and pi r squared h. The only thing I'm missing is the height. It's not the height of the whole cylinder now, it's this height here, between here and here. And working out there too, I leave pi in it again. 288 pi is equal to 144 pi h. Divide both sides by pi. Then I divide in there and I get a height of 2 centimetres. And the question was, how much did the water go up by? And it went up by 2 centimetres.